Okay, hey, I am continuing on with section 1.5, day 2. We are hitting example to be. To be or not to be. There we go. All right, let's look at 2b. And once again, it's a composite function, or really it's not a composite function, it's an addition of two functions. The interesting piece right here that you probably caught your eye was g of x plus 1. They're like, oh, what do I do with that? So I know what I would do just from addition property. I would want to break this out, right? This would be my first go-to. Kind of the easiest approach to limits is addition. Let's just break them apart. When I look at that, this would really then indicate, okay, if I can evaluate the limit at 1 for f, is there a limit? Yes, indeed. The left and the right side come together at a height of 2, don't they? Plus the limit as x goes to 1. This really means I'm kind of doing a g of 1 plus 1, doesn't it? So I would be looking at 2. Oh, dang it. We got discontinuity. G of 2 is a discontinuous. So discontinuous here, and that's gonna pose some problems. So I don't know what the limit is there at g of 2. Well, I do know it doesn't exist. But that doesn't mean that this addition of the limits doesn't exist. So we got to delve a little deeper. And the easiest way to do that is to, so deeper thinking would involve what? What would you try to do? Yeah, you're right. Let's go back to the basic meaning of limits and do a left and right approach. So I'm going to approach f of x from the left of 1 plus the limit as x approaches 1 from the left of g of x plus 1. Does that help us out? Is there an answer to this question? Well, we know the first one because the left and the right both are 2. So this is going to be a 2 for the f of x one. And g of 2, but it would be a 2 minus, because it's going to be a little bit smaller than 2, would be 2. Okay, that's coming in at 4. Then I would take the limit as x approaches 1 from the right, f of x. I know, so much writing, just get used to it. Don't take shortcuts, because I will count it wrong and the AP will count it wrong. So from the right of 1, well, from the right hand side of 1, we have that f of x approaching 2 for height. The limit of 1 plus, so think of 1 plus 1, gets me a 2 plus, doesn't it? So from the right of 2, oh, right of 2 looks like it's going to be a 3, doesn't it? Oh, bummer. So I'm getting 5. Does the left equal the right? Conclusion, 4 does not equal 5. Therefore, the limit does not exist. It DNEs on us. Okay, bummer. But that shows you how to approach that. All right, example 3 has 6, 7, 8 examples. It goes A through H. I would like you to do A. Pause. Try it on your own. Is it asking for a limit? Read the notation. Okay, hit pause. Coming back at you. This really is asking for a point. What is the function? G evaluate at 4, then put that into F. So G evaluate at 4, where is G? G is here. G, oh gosh. I might have to read my own copy. 1, 2, 3, 4. It's the peak here, and this value is a value of 6. That is very blurry for my viewing on the smart board. Now, so 6 is the outcome, isn't it? And then that goes into F. F of 6, here's 6. F of 6. Oh, gosh, I remember f of 6. Where am I? I'm struggling here because I'm trying to find the dot. This looks like the dot on our piece of paper, and it looks like it's a 6-4 combination, so that must have a height of 4. I would get an answer out of 4. If you want, go try C right now, because that's going to be a similar approach, isn't it? Pause. Do see on your own. The answer I came up with this one is f of, well, yeah, it would turn out, f, g of 0 turns out to be -2, so I'm going to do an f of -2. F of -2 turns out to be 1. If you want to make a note off to the side, you can say g of 0 was -2. All right, for B, B is a limit question, okay, and it's a composite. So in my mind, you don't have to write this, but if it helps you, this is my initial thinking. I would love to get by with the easy cheesy way of putting f on the outer side, figuring out what the limit of g of x at 4 is. Well, g of x at 4 turns out to be, I believe that was 6 up there. And then, so this will end up looking at f of 6. What happens at f of 6? F of 6, oh, we got issues, don't we? Because the limit, those are open circles on each of those. The left and the right do not exist, or do not agree, so the limit does not exist, or yeah. So what we have to do, I'm just going to say not continuous at x equals 6. So this means, yeah, delve a little deeper, think a little deeper, and let's look at this again. So when I did the limit from g of x, I noticed that I was coming up into 6. I'm coming into 6 from below. So this comes into 6 from below. That makes sense. That means I have a 6 minus. So maybe rather than just looking at 6, I can update this and say, look at 6 from the left side. That I can do over here. So 6 from the left side says I'm coming into a height of 1. For D, see if you can figure it out. Do it on your own. Hit pause, and then we'll walk through it. Welcome back. The answer for D turns out to be 3. Did you get 3? Once again, we're going to push that outer function to the outside of the limit, and let's just explore what's happening in at g of 0. So we begin there. G of 0 is what, a -2? And it's coming in from the above side, so comes into x equals 0 from above -2. So that's like a -2 plus. So that's like -2 plus. So that's how I'm going to evaluate f now. I'm going to look at f from -2, but the above side. So that'd be like a -1.9-ish, right? So I go over to my f function, and I'm looking at 2 from the right-hand side. That means I'm following this branch, not down here, because that's from the left side. From the right side, it looks like 1, 2, 3. Height of 3. The answer is 3. Well, you know, once you start doing these over and over, hopefully you're starting to see some tricks of the trade and work through those. All right, E looks funky, doesn't it? 1 minus f of x. We're coming into 6 from the left. Okay, so let's say f of 6. Okay, I'm trying to think of how I want to write this. I would explore f at 6 minus and just kind of figure out what is that. So f at 6 minus 6. 1, 2, 3, 4, 5, 6. So 6 minus is going to be this branch. That is a height of 1. Now what I hope to do is put in 1 into that spot so that the limit as x approaches 6 from the left of g of 1 minus f of x really can be thought of as g evaluated at 1 minus 1. which really leads me to a g of 0. Is there something, a limit going on at 0? Yeah, it's -2, isn't it? Yeah, that will work. Yeah, I like that. F. Just give it a try on your own, because you know the only way you learn is really taking that big step forward and doing it on your own. You're coming into 3 plus. You're squaring 3 plus. That's going to look like a limit as x approaches 3 from the right of f evaluated at 15 minus x squared. But now for this x squared, my brain bubble is 3 plus squared, which really equals a 9 positive, doesn't it? Bigger, something bigger than 9. So if I let, here's one way you can kind of show this. I could let u equal 15 minus x squared. So u would be 15 minus 9 plus, well, 15 minus 9 is 6, but if it's a little bit bigger than 9, it's going to be a 6 minus. So then I could rearrange this and say, okay, now let's evaluate this limit, switching my indice down below to u and calling it u 6 minus. That'll give me f of u now. So now what I'm looking at is f of 6 minus. F of 6 minus, over here 6. 6 minus is a 1. Answer is 1. I like this notation, and when we did this one, I was almost tempted to switch that up because it makes notation easier to talk about. You can see how that was able, you know, we were able to do some substitution there. And yet I can show all my work and show my thinking. There is, I know there is 2 more problems, and where are those? H, there they are. Okay, H, G, and H. It's all one block. Okay, can I move that block up? Yes, perfect. Okay, 2 minus. So if I'm 2 minus, what I'm doing is 2 minus 2 left of 2 squared, right? It gets trickier just verbalizing this. So 2 minus 4, but if I'm squaring something less than 4, I'll have something less than, or something less than 2 is squared, I'll have something less than 4. So it's really 2 minus a 4 minus. So that's going to be a -2. 4 minus would be like 3.9. So that's going to be, oh gosh, 2 minus 3.9 would be like -2.1. Why am I struggling on this, you guys? 1.9, a -1.9. So that'll be a -2 coming in from the left side. Yeah. So I thought of this in my head as 2 minus a 3.9. That gave me a -1.9. That's what helped me kind of decide that I'm coming into -2 from, the positive side, because -1.9 is larger than a -2. Oh, I'm glad I wrote that out. Okay, so I'm going to let u equal that. Then I'm going to update my limit statement. So it'll be a u equal, u approaches -2, but from the right of u, because I'm replacing the 2 minus x squared with that u. And then I evaluated it. So g of u, sorry about that, g of u, because we got that g. Now, what is g of -2 from the right? G of -2 coming from the right-hand side looks like it'd be 0. And I just want to make sure, yep, got the right answer right on that. All right, H, if you want to give that a try, hit pause, and then come back. This is one you're going to have to do from left and right approach. Okay, welcome back. Answer turns out to be 3. It is one where you're going to want to evaluate x. Oh, we're going from -2. Got it. It's just I'm not sure that was supposed to be -2 from the left. Although it says -2 from the left, so this actually is going to be kind of an easy one. We'd evaluate inside first and then evaluate on the outer. So I still have my outer function. My inner function, f of x, -2 from the left, -2, oopsie, -2, oh, come on, right. -2 from the left is approaching 0. So 0, it's approaching it from, not that it really matters, but from the above side. I don't think it's going to matter on this. So f evaluated at 0, because it behaves so nice and we don't have discontinuity, it's going to be whatever that height is. Uh-oh. And that height is not 6 like I was getting. How did I get a 3 out of that? Oh, this is fine because when I did my problem, I did it without, sorry about that, I did it without the minus sign up there. My notes have that negative, so let's just go ahead and do from the negative side. All right, the homework might be a little bit tricky. There is a circuit worksheet for 1.5, and it has a reference page that has just functions that you can read like we were doing on our practice problems here. And you're going to do, the first problem, get an answer. Whatever my answer is, I'm just going to say, this looks like a 6. I can't quite tell. If it's 6, then this becomes problem 2. And then whatever answer I get here, I find that answer. Maybe this was the answer and so forth. Okay, and then this will become problem 3. Once you get done with your circuit, you should come back and have your last problem have that answer that was in problem 1 so that you complete the circuit, however that was, so that my starting point and my ending answer end up matching. All right, have a great day.